Hi everyone, can you see my slide?
We see your desktop.
Oh, okay. I think I'll share again. I did.
Now we see the slides. Do you just need to hit slideshow? Yep.
Okay.
Mhm.
Okay, thank you. I'll make it full screen view. Hi everyone. Sorry, I'm Sai, Metadata Library for UCF. And I'm glad to be here today to present with my colleagues Jane and Ying, as well as our external collaborators Eric and Li Hong. Our topic is transforming metadata workflows with AI, a case study at UCF libraries. We know that AI has the potential to AI has the potential to reshape many areas of technical services, including automated metadata extraction, natural language processing, such as assigning subjects and summarizing content, and the data cleaning and the quality control for catalogers. AI can automate workflows and streamline processes, eliminate repetitive tasks, and increase efficiency. Today, we'll discuss a few projects at UCF libraries, including using the OpenAI API to assign fast headings and keywords for both digital collections and the traditional MARC collections. For our first project utilizing the OpenAI API for subject assignment, we chose the Florida Solar Energy Center collection. We initially used API 3.5, then switched to API 4. After evaluating the sample output, we incorporated OCLC's fast recognition service into the process. We conducted the comparative studies of OpenAI API 3.5 versus 4, as well as AI-generated terms versus agency supply terms. The resulting datasets were loaded into our digital commons-based IR the spreadsheet. For more information on these tests, you may refer to the linked previous talk. So besides digital collections, we have also been working with MARC collections, including honor thesis, ETDs, and RTDs. We exported selected MARC fields to a spreadsheet using MARC edit, divided them into smaller sets, and ran the Python code for each set. We then reviewed the generated terms for sample sets and adjusted the prompt accordingly. After some post-AI processing in Excel and MARC edit, we loaded the data back to OMA. So here is our prompt. In constructing it, we considered defining our role as library cataloger, adjusting the number of terms to be generated, providing examples, ordering terms by importance, and setting restrictions. Next, Eric will talk about the Python code he developed and the AI-related aspect of the data flow for these projects. Thank you.
Okay, so using the prompt that I just showed on the previous slide, I created a chatbot on po.com, which is an AI chatbot platform that has access to many different LLMs. So the chatbot can generate fast headings based on users' input into a chat window with a book title and an abstract of the book. So I was hoping that this would be useful for metadata librarians to assist in the day-to-day work. Now, in the interest of time, I'm not going to demonstrate a chatbot here, but I strongly suggest you go try it out in that link. And if you do, you will be utterly disappointed because it is prone to the infamous hallucination problem. In other words, it would make up fast subject headings that sounds plausible, but actually are not valid according to the fast dictionary. So rather than just using a simple chatbot that we know will sometimes hallucinate, I developed a programming logic to make sure that when it does hallucinate a fast heading, then we will perform reconciliation on that term. So fortunately, OCLC already has an API for looking up the fast dictionary, which I can make use of in my programming logic. So here's the overall flowchart. So first, I read in a title and a summary of a book. Maybe it's from an Excel file, or maybe it's a user's manual input. Then I asked ChatGPT, or more precisely, the OpenAI API, to generate a list of fast headings based on the title and summary of the book. So these generated fast topical headings could contain hallucination, as I mentioned. So we feed them one by one into the fast linked data API on the OCLC website. Now, if the API verifies that it is indeed a valid fast topical heading, then that's great. We'll just output it straight into the Excel file. That will be used downstream on of the workflow. However, if it is not a valid fast heading, then the OCLC API may or may not return a list of suggested fast headings for us to choose from. Now, in the case that it does, then we would query ChatGPT again using the list of suggested fast headings and let it choose the best one based on the given title and abstract. And finally, we'll output this validated fast heading into an Excel file, again, for downstream of the workflow. So based on the logic shown in the last slide, I used Python scripting to generate and reconcile the fast heading over many records. Now, in the interest of time, we're not going to go over the code, but I've recently conducted another experiment using Python to read in a series of book records and generate LCSH subject headings for them. So the code is actually found here in the link shown on the slide. It works quite similarly to what we're doing in this project, but without the reconciliation, because LCSH is notoriously difficult to reconcile as compared to FAST. So I suggest that you can go check it out. And in case you're interested on the topic of using ChatGPT to generate LCSH headings, you can check out the article that I've recently co-authored and published on cataloging and classification quarterly. Next slide, please. Okay, so now for those of you who are interested to learn more about the technical aspect of using programming using or programming with LLMs, I suggest these two websites, OpenAI API Starter Tutorials and deeplearning.ai, as shown on the screen. So I now pass the time to Jean to discuss about the evaluation of the test results.
Thank you, Eric. For the results, we used a rubric that measured both the relevance and the validity of the AI-generated fast terms and keywords. For this example, effects of school meal consumption on school-related factors in elementary school-age children, both the AI-generated keywords and the fast terms were valid and either highly relevant or medium relevant. Overall, the author keywords were more focused on general concepts, while the AI keywords and fast terms were more related to the study object, methodology, and findings. Next slide, please. And here's the MARC record associated with the previous example. Note that the AI-generated fast terms have been added in the 650 indicator 7 fields. And next slide, please. And here's an example of an FSEC institutional repository record that has been enhanced with AI-generated keywords and subjects. Originally, the record had only the local subjects, buildings, and building codes, but now has a much broader array of keywords and subject headings that will enhance discoverability. And next, Ying will reflect on opportunities and challenges for AI-assisted cataloging.
Hi, everyone. Yeah, and we've already discussed many of these opportunities and challenges in previous sessions. The one I wanted to highlight most is really the AI-assisted cataloging can be very valuable when you are dealing with a very short staffing situation, because it could create some efficient metadata and or at least just valuable resources. And really the key here is we are creating more discovery tool for users, be it fast or be it keyword, be it other subject headings. And next, and then really how to use and how much of AI-assisted AI should be integrated into the cataloging workflow. It really depends on the local institution, local situations. Just keep in mind that the core competencies that are needed here is really the cataloging and both the AI proficiency. And really, as you see, that the cataloging skill set is very essential in evaluating how well the AI tools are used. Of course, you need to be able to construct a very good prompt. But really, and also the AI app, as I mentioned, that we switched to some apps that would be a version 4, which costs money, and we wanted to see how compared to the free one. But the number one thing, reflective thoughts of my portion, is be open mind, be willing to experiment and to explore. Don't be afraid of failing. So with that, I'm going to move to the next presenter.
We are at time. How long is the presentation? How many?
Oh, there will be just 1 more minute, I think.
Okay, thank you.
Okay, thank you. Okay, when we implement AI in technical services, including cataloging, we should pay close attention to the ethical challenges and risks that AI might pose, such as biases in algorithms, risk to data privacy, job displacement of library staff, lack of transparency in decision-making, and misrepresentation of information. It's critical for library staff to balance AI integration with maintaining human touch in the workflows. The successful implementation of AI in cataloging requires careful consideration of both its benefits and potential drawbacks. The Cataloging Ethics Steering Committee issued the Cataloging Code of Ethics in January 2021. We will need a similar code of ethics for the use of AI in cataloging. Next slide, please. To prepare for the future, how can we take better advantage of AI technologies to increase productivity and efficiency in cataloging? Here are some thoughts. First, we should have a better understanding of AI's capabilities. This will help us to implement it more effectively. We should know not only the benefits, but also the risks associated with AI. Second, we should develop more AI skills to keep up with the trend toward machine learning and AI-driven automation. We should reframe our thinking to meet the future challenges. Third, we should establish ethical standards for AI. AI can provide insights analysis, but it lacks the human ability to understand emotion, culture, and diversity. Thank you. This is the end of our presentation.
Thank you so much. And if you have any question, you can type in the chat. I think I saw a question earlier asking about how we add